How's it going, everyone? Mr. Frost here. We're going to be looking at exponential functions today and their graphs. So, kind of what exponential functions are, what they look like, how they behave, and also some real-life applications of exponential functions. That's what we're going to be looking at today. So, to get us started, I have a real-life situation here. I want you to look at a bacterium, this bacterium here, and this bacterium happens to clone itself every hour. So this is called binary fission, and what's happening here is the bacterium, this whole thing here, splits itself in half. You can kind of see it happening right here in the middle. It splits itself in half every hour and creates a clone of itself. And exponential functions can help us predict how much, if this process were to keep continuing, how many bacteria we'll actually have eventually, depending on how much time goes by. So after 2 hours of bacteria, or 2 hours, how many bacteria do we now have? Well, we start with just 1, and we can make that 1 just 2 to the 0 power. Remember, anything to the 0 power is going to be equal to 1. After 1 hour, we just have 2, right? We start with the 1. We'll write it up here. 1 hour goes by, and it splits into 2. So now I have 2 bacteria, 1 here and 1 here. After 2 hours, well, now we have each of these 2, this one here and this one here, are going to split into their own 2. So now we have, what, 4? So that's 2 times 2, right? This is going to split into another 2. This is going to split into another 2. So we have another one there, another one there, another one there, and another one there. And we can show that by doing 2 times 2, which is just 2 to the 2nd power, which gives us 4 total. And what about after 3 hours? Well, after 3 hours, this one's going to be split into another 2. This one's going to be split into another 2. This one, and then this one. So after 3 hours, well, if we follow the pattern that we were getting here, I started with 2 to the 3rd. After 3 hours, we'll have, I started with 2 to the 2nd, and if we follow the pattern, I'll have 2 to the 3rd. Well, that's just 2 times 2 times 2 times 2, right? And that gives us, well, 2 times 2 is 4. Times 2 would give me 8. And then after 4 hours, well, that would be 2 to the 4th power, and that's 2 times 2 to the 3rd power. 2 to the 4th power gives me 16. So, might already be obvious here, but we're doubling after every hour. So what would happen after 10 hours? Well, that would be 2 to the 10th power. And 2 to the 10th power is, if I get my calculator going here, 2 to the 10th power is going to be 1,024. Whoops. Came out a little bit funky there. Now, how can we model this relationship with a function, right? We're looking at exponents, right? The process here is called exponentiation. If it keeps doubling, we keep multiplying by 2, we're exponentiating. So how can we model this relationship with a function? You might already have an idea, right? We have a 2 here, and the exponent itself is what's changing as we increase over time, right? It's going from 2 to 3 to 4, and it's going to keep going up. So that's what's varying, is the exponent. So how might we model this with a function? I will take a second, let you guys come up with some ideas, and we'll be back.